I try to do a little 7-stone diamond ring here with shared prongs. I'm going to show you guys how to do that. Obviously I already have a shank here. It's my 2.5 millimeter stone. One of the things I always do with rings like this is I take my original ring rail, which is a size 6.5, and then I add one which is one size bigger, and I make sure that the culettes of my stones are always off of that, so that if I had to grind a half a size or a full size out of this, I wouldn't actually have to cut the ring, because this is actually pretty minimal. It's way less than half a millimeter. So I actually think it's better sometimes if you tap or grind than if you cut, if you're only going up a little bit, especially if this was a ring where the diamonds went all the way around. You'd have to either add a whole diamond or completely rebuild the ring. But if you do this, it'll save yourself a lot of energy if the customer comes back in and maybe they've gained a lot of weight, or they're pregnant, or they want to change the fingers or something like that. So we do that. So first thing we want to do is act like we're going to build this all the way around. So I'm going to do this, and I already know that center polar array, I know that 25 is the right number. Odd numbers are great for doing this because I've got a gap down at the bottom and I've got a stone centered at the top. So the first thing we're going to do is turn off our shank. Then we're going to drop these for the moment. I'll actually be dropping a bunch of these soon. I'm going to rotate it upwards like this. And then we're going to build a prong. Now, if I go in and I use the Gem Vision Prong Builder, which is this tool, where it says Prong Builder here and Prong Adder here, but whatever. I'll throw these in here. We get these things, and you can play with them, but I think they're rather insufficient for holding anything. We're looking at a diameter of, we're looking at metal that's, if we're lucky, 7.78 tenths of a millimeter. That's pretty insufficient in my mind. Plus, a lot of chances for porosity or casting failure in there. So what I like to do is I like to center up here and do an oval. So we're going to turn on our grid snap, pop right to that grid, and then we're going to do an oval prong that's like this. Doesn't look severely oval, just a little bit oval. I'm going to make a second one just like that, and then I'm going to make this one a little bit bigger. And then I'm going to slide it in like that. And then we're going to take these, and the base one, which is a little wider, we're going to slide up underneath our ring rail, and this one we're going to slide right above the table. And then I like to have a little arc to this, so I'm going to pop that and that with an arc tool. Put just a little bit of an arc there. And then we will sweep surface 1, sweep 1 from here to here. That's our basic prong. Now I'm going to take this line, cap, F6, hit MSR, enter, and then hit it again, F6, and then I'm going to profile cap tool, pull that up, join this and this, then I'm going to cap that. Alright, so I like this because since it's a little wider at the bottom, I think it's easier for the metal to flow up. Since it's oval, I think it's easier to hold the two prongs. And honestly, once you finish it, I think it looks as good or better than any of the prong builder prongs. So I'm going to take this. I guess the first thing I'm going to do is cut the finger rail off of it. Turn this blue. to transform by 4, 25. There we go. Look at those prongs. It's gorgeous. And then we'll mirror them over for here. And now what I'm going to do is I'll turn all this off and I'll go back to my, turn it on. Actually, I'm going to flip this around. Turn these guys off. Oop, sorry, I need one. That one. So I'll get all these off. Transform by 4. Alright, so now we're going to take and flip this entire thing over. And the reason I deleted those 3 on the bottom was so I could see what I was doing. That's the only real reason. So now we're going to go into one tool I do use, which is the bezel builder. Although you don't have to. So we're going to throw this in here. I need an under bezel. There it is. Now the one thing I got to do here is I have to delete my extra piece, my extra rail. I want this to come out a little bit. Enter. I'll take this, which is a little heavy, but it's alright. And again, transform. And there we go. So we're going to turn our shank back on and just delete all the ones we don't need. Oop, need that one. Alright. And so there we go. 1, 2, 3, 4, 5, 6, 7. Gorgeous little 7-stone ring. And I think this will cast quite well. I probably could fill this in here, but I don't really think it's necessary because we got plenty of overlap. So that's how I would do that. Alright, Gary, let's see how you would do it.
Hey Joel, thanks for the handoff. I think this is probably going to end up being my favorite project of all the ones we've done so far. I note that you started out with the shank already made, finger-sized curve and a gemstone, so I'm going to start out the same way. In addition to that, over here in the panels, I have created in the layer tab of the panels portion of the Rhino screen here, I've created some layers too, and hopefully as I work through this I will remember to put stuff on layers so we get that nice colorful finish differentiating the components of this. So I'll get started right away here, and I'll pop over to the top viewport, use the circle command with grid snap on to make a 2.5 millimeter circle, and then I'll come down to the front viewport, and with the quad OSnap tagged, I will create a polyline that starts at the quad, and then I'm going to use relative position in Rhino, relative negative 0.5 for thickness with an angle of 41 degrees. And note that this automatically positions the second control point in this polyline that I'm creating at the same pavilion angle, or the same angle as a pavilion of a round diamond. So this will make a perfect seat for that stone. Now if I shift constrain down here a little bit farther than I know it's going to need to be, and then I will turn on, I see Smart Track is already on here, so I'll hover over this point until it lights up, and that brings me a positional indicator here and a snap to, so that I am perfectly vertical from that quad position, and then I will come back up here and tag that. Then I'm going to play with this shape just a little bit before I proceed, and that means I'm going to explode this. I'm going to rebuild these two lines with going from 2 control points to 4 for each of these lines with a degree of 3, which is going to give me the ability then, once they turn on these control points, to be able to just bring this out into a smooth arc. And I had grid snap on there. I'm going to turn control points on to this line too, so that when I turn off grid snap and grab all of those control points, I can just bring this out just a little bit more. Yep. And maybe we'll just continue to play with this just a little bit, just to give this little sort of barrel-like bulge that I want to do, and create just a little bit of tuck down here. And you can play with that indefinitely, but let's accept what we got there. I'll control join them back up, and then I will use sweep one rail command, using this as a cross section to go all the way around that curve. And let's go ahead and put these curves on an under bezel curve. I didn't make that yet. Okay, so we're going to make a layer really quick. Under bezel. Boom. Sorry about that. Under bezel curves. And we can then hide those because we really probably won't need them anymore. Let's go down into perspective. And now I'm going to do one more thing here, two more things actually. We'll put that on the under bezel layer, and now I'm going to use the solid command to fillet edge, and I'm going to fillet this to 0.03 millimeter radius. Let's try that. And I want to chain the edges, so all I have to do is touch this once, click on through to accept, and now I have a little bit softer edge on that, which I like, and it creates for a little better castability, I think. Okay, let's come here, turn grid snap back on. In the top, we can just pull this down so that it's perfectly positioned underneath the gemstone, and we come to the front, and we can pull it up so that it actually acts as the under bezel. See, oops, maybe what I need to do is turn off grid snap and pull that down to just right there, right the girdle, right where it should be. Okay, perfect. And this does extend down into the finger space right now, but that's really not important at all. Let's select these two things, and let's turn off our shank, and we can turn off the finger size curve. We really don't need it right now. And I like your polar array idea, so we'll do a polar array from the 0 position, and I know that 24 is going to fit around here. I must have made my ring size a little smaller than yours, Joel, because I think you had 25, I have 24. But part of that is to explain that it really doesn't matter in this case whether we have an even or an odd number of stones. You can build this around any finger size basically, as long as the stones are going to fit around there. And this is the slickest trick that I learned while working through this process of making this video. Something I knew existed in Rhino, but this gives me an opportunity to use this in a different way. If we touch the control or the rotate curve here that's built into the Rhino gumball, we can just move this manually wherever we want to, right? So we could try and line this up so that it's between the gemstones, and we might be able to do a pretty good job. But there's a much more precise way of doing that. And because Rhino does math, we can touch this, and we know we have 360 degrees in a circle. We've divided that by 24 sections. That's the gemstones that we laid up in there, right? But we only want to go half that distance in our rotation. So we do times 0.5 and watch what happens. Did you see that? Rhino rotated it, which I know it's going to be 7.5 degrees because I can do math too. But if you have something, a more complex problem, you can just let Rhino work out the math for you, and that gives you the exact in-between position. It's rotated this whole thing to the exact in-between position, so that now we can go to the front or the right viewport and use the construction plane to build a curve. Let's make sure that I don't have any O-snaps or grid snap on. I don't want that. So we're going to start just a little above the stone here, and I'm going to give myself 3 control points. And I want a little tuck. I want to tuck underneath just a little bit here. So we've got our 3 control points. I'll end the curve there. Go into perspective viewport again, and let's see what we've got. Okay, let's pipe this, and I'll use a pipe with round caps, and we'll do 0.3 at the top, 0.4 at the bottom to give it the taper, which I really like your idea about that, Joel, a lot. And I don't really want to work with this curve anymore, so I'll just delete it. Let's work directly with this. I love your idea of making this a little bit wider, so we just stretch it in the x-axis here a little bit, right? And let's pop back over here and see, we want these prongs. What I really want to achieve is to get the prong to stand nearly straight up, but I also want it to tuck. That's what I was looking for right there. I want it to tuck kind of underneath. I want it to tuck into the under bezel as I go around here. So I'm going to try and create just a little bit of a interesting feature if I can do that. And let's see. That's probably tall enough. Let's look at this in perspective view and see what we've got. Yeah, I like it. Okay, I'm going to make that prong even just a little bit bigger in the y-axis. Right? And that's probably about good. Maybe I'll fatten it up even just a little bit more. But it's still a little bit longer. It's still oval, kind of. It's longer in the x-axis than it is in the y-axis. A little bit more. And move it in. Okay. And now you can see how it sort of impinges on the gemstone there. And I think I like the angle pretty good. Okay, that's good. And I'm going to get the tuck I want out of this. So now we do mirror this in the x-axis to get its sister over there. We can touch shift select so that we have both of these, and we come down here and do the same polar array that we did for the whole shebang so far, starting at the 0 axis, doing 24 of them, click through to accept, and there we have it. Now really all we have to do is to eliminate, oh no, we got to rotate this back. Okay, so we could do that formula again, but we know that all that formula actually is already there, so we can just do it again, and it rotated it right back to the middle. That's the 7.5 degrees so that we were talking about. Okay, now we can go 1, 2, 3. We want that prong. So if I'm really good here, I should be able to select all of that stuff with one fell swoop and delete it. We bring back, oh, we don't need the shank yet. What we need to do is to bring back this curve, and we need to trim this stuff. And I can do that by just extruding with the gumball. I can cap this thing with a simple command, and then I can select, I don't need that curve anymore. I can select all this stuff, do a Boolean difference using this, boom, and I could have had Rhino deleted, but I didn't, so I'll do it manually. And now all I have to do is bring back the shank, and we're done. There we go. Now, I think I could have rotated those prongs just a little bit more, but I like it. And if I was making this for manufacturing, I'd probably go back in and fillet some of these edges to soften them around. But this is as far as we're going to take it for the video. Thanks again for the opportunity to work with you, Joel. These are incredibly fun for me, and I hope they're equally fun for our viewers. Thanks a lot for watching, and we'll see you next time. Gary Dawson here with Rhino Jewelry CAD.